Yeah, thank you. So my name is Hernitschek, and I'm leading the point of interest broker tutorial, and I'm the primary developer of Broker. So this broker should enable users to get updates on variable stores in predefined regions, such as stellar streams, dwarf galaxies, globular clusters, as well as regions predefined by the user. The service will then constantly will be updated with the regions and will update the alerts within these regions. And it can be easily queried for objects associated with a given region, such as from recent publications. We are currently processing ZDF streams. And this tutorial is now giving some examples on how we calculate Likert features and how we cross-match alerts to external databases. Here, the code is simply executed on one example alert Avro file. And let's start with a bit of setup. So we're first installing some libraries if they're not present already, like Fast Avro, Able PI, and astroquery. After that is done, we have, of course, some imports for some libraries, and then the more interesting stuff begins. As I say briefly, we are calculating a lot of features out of Likerts. We use this to classify Likerts. And for this, we need to calculate something like periods, something like amplitudes, something like temporal baselines, and so on. And also we are doing cross-match to external services such as Simbat. And here is just one function that is querying Simbat to cross-match an object found by an alert. We have cross-matches for several databases and services, usually over CDR6 match to Simbat, then also querying WISE. We are querying, in addition, to mass. And we go down in the code, we see we are also querying the VSX. This is a variable store catalog. So we are cross-matching based on coordinates and, if possible, also on magnitude. What we get out typically is an object name, then the coordinates of the cross-matched object, and some additional information such as a variability type, such as associated galaxies, and so on. And in case the object isn't found, what happens regularly, we get an unknown object returned, or if there is a connection outage, we get a timeout information. So this happens quite often when cross-matching something like VCR, I found out. So this is why we implemented that. Then here you see some functionality that is used to calculate Likert features, make histograms, and so on, and finally plot the Likert. So that's a lot of code. If you're more interested in that, you have to take a closer look on that. I can now show you what we get when we execute this code. So first, we are loading the external astronomical databases. So in some cases, we're just querying remote, such as for Simbat, but for others, it's more convenient to have them locally. These are, for example, smaller databases, like especially for our library stores or for the assassin catalog. Not everything is online. We had to get an additional catalog that is stored locally. Then we are loading them. Here you see what is going on with the assassin catalog. The variability flag and the asteroid flag is stored locally. So the code says I was able to load the database, and now we are loading for this tutorial one alert. The alert is stored on this Google Drive. When we load it, we see it's okay, and we get the candidate ID and an object ID. The object ID is used as we're we're stacking the light curves. So we're not only processing the light curve content, the 30 days that's stored in one alert, but we're concatenating the light curves to get everything that we have from one astronomical object. This is especially important for the feature calculation to get precise period fits. And then we are plotting first the science images. It is always the science image, the template, and the difference image. As we're using this difference imaging also to find certain types of objects. And then we're plotting everything. It is not only the 30 days within the alert, but everything that we can find for this object. Here in this example, as we just loaded one Avro file, it is just the content of this Avro file, but if it would find more, it would just concatenate the light curve. The feature calculation is done to get some information that can then be fed to a classifier. Features are also sometimes called metrics, and they're describing the light curve characteristics. Here you see it's a long row of different features that can be calculated. It is something like structure function parameters. They describe basically the time scale over which variability at a certain amplitude is occurring. And then it's calculating also different typical astronomical information such as colors, amplitudes in given bands, Lom's-Gauge periods, doing a Fourier decomposition, and it is giving all of that in an array. You see here are some non-values. This is intentionally, as for shorter light curves, certain features just cannot be calculated reliable. So we skip, for example, the structure function if you have less than 10 light curve points in a given band. Here, as we're just reading in one Avro alert, we have to skip quite a lot of features. So for true light curves, usually all or almost all of the features will be calculated and then will be fed to our classifier. The next step is we're doing cross-matching to the external databases. This is, for example, to find objects in close proximity to galaxies. This is important for doing, for example, supernova identification. And also we want to know what other databases think about certain objects. This is also used in the training process for the classifier. Here you see that a lot of code is executed to carry out the cross-match. We're also doing more advanced or more specialized cross-matches in case an object was identified already as a certain type of object. So for example, when Simbad says it's an Euleric star, then we're also trying to find these objects in our pen stars Euleric catalog to get more information, such as the period that was already derived from pen stars, and then we can compare this to the period that we get from right now ZDF or later on from LSST. We're also cross-matching then to all the other catalogs I described before, such as the all-wise, the 2-mass, the assassin catalog. And what we get in the end is a list of cross matches. Object is found here in almost all of the databases. Of course, I have chosen this object intentionally to show that the cross match is working. So it's a Simbad object here identified as that star. It's also found in all-wise. It's found in 2-mass. And assassin isn't knowing this object. This happens. Then
2 more minutes, Nina.
Yeah. Then it's found close to a galaxy. To that galaxy, NET can sometimes deliver some detailed information such as diameters of a galaxy. This is especially interesting as then we can check how far away from the center of a galaxy an object is, for example, for identifying supernovae. But here just the NET catalog is missing this information for this object. Also, the variable star catalog is not knowing this object. So that's basically what our broker is doing regarding identifying objects and cross-matching. And for that, I leave it with that. And if you have any questions, you can just type them in a Slack channel. Thank you.
Okay, thank you, Nina. I don't see any questions yet in the Slack channel. So maybe the Eon and Tom team want to take over the screen. And just tag Nina in the Slack channel if you've got any questions for her.